afternoon, my highly esteemed viewers. The title of today's tutorial class is Alkyl Halides. From the name, it is obvious that there is the alkyl component in that name, and there is in this compounds, and there is the halide component. So alkyl halides are compounds, hydrocarbons, particularly in which one of the hydrogens have been replaced by a halogen, say chlorine. So if this H has been replaced by this chlorine, then the compound becomes a combination of the ethyl and the halogen. So you have what you call the alkyl halide. Okay, so very quickly, there is a need to look at the classification of alkyl halides. How are they classified? First, you have the primary alkyl halides. Primary alkyl halides. And this classification is basically about the location of the halogen in the alkyl halide. So when you have the halogen hanging on a carbon atom that has two hydrogen atoms attached to it, you call that primary. If you have, so that's primary alkyl halide. You can also have the secondary alkyl halide. Okay, that is when the halogen is connected to a carbon atom that carries only one hydrogen. So if you have bromine here, for instance, this is a secondary alkyl halide. And thirdly, if you have a situation in which the carbon atom that carries the halogen, iodine for instance, if the carbon atom that carries the halogen does not carry any hydrogen at all, that particular alkyl halide is a tertiary alkyl halide. Tertiary alkyl halide. Okay, so having spoken about the uh, tertiary alkyl halide, I think it's important to also talk about the nomenclature of alkyl halides. Nomenclature. How are they named? There are the common names. Common names, and there is the IUPAC names. Okay. For instance, if I have a compound CHHCl, the common name would be to look for the name of the alkyl group and link it with the halide group. So this would be methyl chloride. While if I'm looking for the IUPAC name, it's going to be, the IUPAC name is going to be chloromethane. Okay, chloromethane. You will see this better when we go further to say if you have this H, 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 and Br. Okay. Of course, the common name of this should be, Jesse, can you try that? Ethyl what? Bromide. Okay. But if you want to look at the IUPAC name, what would you call this? You can also call it bromo. Oh, sorry. Well, 1-bromoethane. But hey, how can I correct this? Okay, 1-bromoethane. Okay, it will become more striking if we use a compound that has 3 carbon atoms, where the numbering becomes more important and prominent. Okay, if you have this, so you have H, 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 and here you have Br. Now, here you need to be very careful. The common name will just go straight to say propyl bromide. Okay, it will go to say propyl bromide. However, it's important to look at this IUPAC name, because the IUPAC name makes us to know the location, per se, the location of the halogen. So this is carbon atom 1, this carbon atom 2, this carbon atom 3. So common name says, what is it, just say?
The common name
Of this, what do you think this will be?
The common name will be propyl bromide.
Yes, propyl bromide. And then, if it's the IUPAC name, you look at the carbon atom that is carrying the bromine. So you use that as a 1, yes. Bromo. Propane. Thank you. So that is the IUPAC name. Okay. Before we proceed, let me just put on one more structure and then ask if you can deduce what the name should be. Okay. I hope someone is not going to get confused. Okay. This is I. Okay. So what's the name of this compound? What is the common name, first of all? Jesse, you want to try again?
Okay. The common name might say propyl iodide.
Okay, you said propyl iodide. Obviously, you were not counting. How many carbon atoms do you have in this compound? 1, 2, 3, 4.
Okay.
So you can't actually talk about propyl. Okay. So let me help you very quickly. You have I know you were looking at these three carbon atoms here.
Yes.
So this is actually a a tertiary alkyl halide. So there are different ways by which you can name it. You can say third, third butyl iodide. Third butyl. This is this is the third butyl, right? Iodide. Okay. Um, if you want to look at the IUPAC name, this is carbon atom 1, 2, and 3. That means carbon atom 2 is carrying two substituents. It carries a methyl group and an iodine atom, right?
Yes.
So you have two you have two.
Two iodo.
Okay, so you want to try? Okay, so let's go.
So two iodo,
Okay,
two methyl
so
propane,
two iodo,
two methyl.
two methyl. Oh, I need to move away a little from here. Okay, so come again.
Two iodo,
Iodo,
two methyl
two methyl
propane.
propane. Okay, that's good. Okay, so that's that about the nomenclature. And finally, it's also important to talk a little about the properties of haloalkanes. And first is to mention the fact that the properties. Okay, of course, when we're talking about properties, we may need to first of all talk about the physical properties, right? Okay, so uh, haloalkanes, that's another name for alkyl halides. Alkyl halides. They have higher boiling points. They have higher boiling points than their corresponding alkanes. Okay, so what does that mean? It means that if you have an alkane and an alloalkane that are of almost equal molecular masses, the one that is the alkyl halide will have a higher boiling point. Why? Because of the dipole moment that exists in the alloalkane. So when you have C carbon here and it's connected to hydrogen, 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 and then here you have chlorine. Okay, chlorine is electronegative, so it will draw electron towards itself. Okay, delta negative, and then this one will acquire a partial positive, like um, a delta positive sign, and this means that the attraction between the molecules will be stronger than when there is no such polarization. Are we together?
Yes.
So because of the polarization, there will be this already polarized, this positive, this negative. So there will be more stronger attraction between the molecules, hence higher boiling point. So that's the first thing to note. That's about uh, uh, the physical properties, the first one. And then the second one is about the solubility. And you can always read about this. You can read about these and read up. The second property we're looking at is solubility. Solubility. Okay. Alkyl halides have little to no solubility in water, um, because you will be expecting that because of the polarization, maybe they should be soluble in water, but actually the solubility is low. Okay. Um, this is because the attraction between the alkyl halide molecules. So we can write here and say little to no solubility in water. Okay, so this is because the attraction between the molecules, the attraction between the molecules, the attraction between the molecules, the attraction between the molecules of the alkyl halide and the attraction between the alkyl halide molecule and water is not the same. It's the attraction between the alkyl halide molecules is more than when you are looking at the attraction between the alkyl halides and the water molecules. So that's the reason why the solubility is like that. And finally, I want to touch on a chemical um, chemical characteristic, a chemical characteristic of alkyl halides. Alkyl halides, alkyl halides, because of the effect of the halogen on the carbon. This is delta positive, delta negative. Alkyl halides have a positive center, which can be called the nucleus in mechanistic chemistry terms. You call that the nucleus, the positive center. So because of that, nucleophiles, you will, nucleophiles. You will know about nucleophiles if you go to if you visit our previous video on mechanism of reactions. So if you visit that, you will see more about nucleophiles, nucleus loving species such as OH minus, Cl minus. They will love such a center, even H2O. They will love this center. So alkyl halides are good substrates for nucleophilic substitution reactions. It's at this point that I want to stop and ask you to um, attempt to solve the following questions, and that is give the name. The first one, give the name or the names of the following compounds. A. Okay, I hope you're seeing that. B. Okay, and then question two. Question two. Arrange the following alkyl halides in order of increasing boiling points. So one is, two is, 3 is I think that should be simple. Thank you for coming to this class, and see you in our next video. Thank you.